All right, I want you to notice that we're going to be doing some algebra. Some of you might be excited about having algebra as opposed to all the geometry that we've been doing. But they're going to pertain to perpendicular and parallel lines. This is the last section of this unit. We'll be having a review and a test after that. All right, we're going to do parallel lines first. All right, this is totally review. This is not on your note sheets, and it's not anything you need to write down because you know it, but we need to kind of just jog our memories. Slope has to do with how high something goes up divided by how far it goes over. The rise over run is what we say. We have a formula you've been using. I remember you guys using that before. And we graphed equations using their slope and so forth. We've been doing that and finding the equations of the line using that equation. All right. The way we found the slope, we could find the slope, is if we had a line, we could draw just as going backwards, we could draw the triangle, find where it met the nice little corners. And we could count down 1, 2, 3, 4, 5, 6. And go over 1, 2, 3. And then we put them in the fraction. Which one's the rise? The 6 or the 3?
6.
The 6. So we would put it in here. 6 on top. And the run is the one on the side over here. It's the 3. We could reduce that. 6 divided by 3 is?
2.
2.
2.
Okay.
6 divided by.
The stuff we've been covering, at least we've been drawing lines. If you had a slope of 2, you'd go up 2 and over 1, which is exactly what was happening here. We'd go up 2 and over 1, up 2 and over 1, up 2 and over 1, and notice it's hitting the line every time, okay? All right, now let's bring in some parallel lines since we got rise and we got run. All right, let's bring in some parallel lines. I have the same parallel lines there on your paper, all right? Let's find their rise over run. Let's find their slopes. So the first one, I've got something here. I've drawn it there for you. I'd like you to draw it somewhere. Find the place where they cross a nice corner. 2 places. If you want to go in between, you can also do that. And draw your triangle a little smaller than mine.
Our triangle's already drawn.
You're good. They're already drawn? Oh, fantastic. So they're already drawn. So I'll bring both of them in then in the world. This one over here, if you count, is 4. And how far over is this?
2.
So if you'll write a 4 and a 2 on your paper. I think I took those out for you.
Mm-hmm.
Yes. Then you can draw the triangle. It's already there for you on there. How high is it? What's the rise on this case? 2. And the run?
1.
All right. If we were to put those into the equation for that slope, that rise over run, we'd have 4 over 2, which equals 2. And we'd have 2 over 1, which equals 2. What do we know about those 2 slopes? They're both 2. All right, so something that you'll need right there. There's a sentence that we're going to fill in. Your sentence says, parallel lines have the blank slope. Same slope. Parallel lines have the same slope. I hope that should make somewhat of intuitive sense. If they're slanted the same, then they're going to be parallel. If one of them doesn't have the same slant or the same slope, they're going to run into each other, right? So to be able to stay parallel, they have to stay at the same slope. Otherwise, they'd run into each other. Okay. All right. Let's talk about perpendicular lines. We're going to figure out the relationship. We know that parallel lines have the same slope. Let's talk about perpendicular ones. What relationship do they have? And I'm going to just tell you outright. And I think you have a place to fill in the blanks there. Basically, slopes of perpendicular lines multiply to equal -1. I'll let you fill in the blank for that. I like another definition even better, and I'm going to show you what this. I'm going to explain this too, but I like another one even better. Their slopes are negative reciprocals of each other. I'm going to give you some examples here. So if I have one of the slopes of, let's say, 1/2, we're going to call that slope number 1. M was slope, if you remember. The word negative and reciprocal is what you need to concentrate on. So if I wanted a slope of another line that was perpendicular to the first line, I'd need the reciprocal. What is the reciprocal? What's that mean?
The upside down.
The upside down. So instead of 1 over 2, it's the 2 over 1. But what about the word negative?
It'd be -2.
So I have a positive 1/2 here, so it'll be a negative there. Let's do another one. Okay? Let's do, so these two lines, if they had these slopes, would be perpendicular. Let's do another one. M1 is going to be -4/5. What's the perpendicular slope going to be? What's the reciprocal of 4 over 5?
5/4.
5 over 4. And what about if it's already negative?
Positive.
Then the other one's positive. Okay? So these two would be perpendicular to each other. Let's talk about what it means then that they multiply to be -1. So I'm going to take these that are a little too big to fit everything I need to put on here. I'm going to take these two slopes, the 1/2 and the -2 over 1. I'm going to take them and multiply them. What happens? 1/2 multiplied by -2 over 1. What happens when I multiply fractions? So I multiply the tops or the numerators, and I multiply the bottom or the denominator. But I want you to notice what will happen. They will cancel each other out. The 1s will cancel. Well, they already, and the 2s. So does it mean equal 0?
No.
No. They equal, when they reduce down to 1. So it's going to be 1 times -1, which will be -1. And 1 times 1 equal 1. So I'm going to get -1 when I multiply those slopes out. Should multiply to be -1 if they are perpendicular to each other. The same would happen with the -4/5 and the 5/4. So let's go to your note sheets. Your note sheets have on them the 1/2 and the -2.
That's what you just did. We're supposed to fill it out.
Well, no, I'm filling it out right now. I'm showing you right here. Here's one for you to fill out. The 1/2 and the -2. I didn't write the over 1, but I could have.
We're still on relationship. We're not on are the lines perpendicular. We're not there yet.
Yeah, you're right. We're over here.
Okay.
Okay, so I did not write the over 1. You don't have to, but you could. If you multiplied those two together, they should equal -1. All right, you can multiply those together. That's the example that I just did. Okay. Let's now decide if some things are perpendicular, yes or no. All right.
Wait, is that what we're on?
Yeah.
That's your next slide. Yes, that's the one. Are the lines parallel? Perpendicular. All right, so let's find the slopes. So let's go back. I want us to come over here to I guess we'll do the red one. You don't have colors. So I have already drawn some dots for you. I want us to find that slope right there. You could do it with the equation, but I like doing it this way. I think it's faster. So how much does it rise?
3.
Yes. And how much does it run? 1, 2, 3, 4, 5, 6. Now, is this line a positive slope or a negative slope?
Negative.
How do you know?
Going downhill.
It goes downhill. So this slope is going to be -3 over 6, which reduces to what? -1/2. Okay, so this first slope is going to reduce down to -1/2. Thank you, Nariah. Let's do the next one. I'm going to draw a line right here. That rises 1, 2, 3, 4, 5, 6. And runs 1, 2, 3. Is it a positive or a negative slope?
Positive.
Because?
It's going up.
Very good. 6 over 3 reduces to? 2 over
6
1,
over
which is the
3,
same as
but 2
just
over
2.
1.
Okay. All right, so let's go over. I've got that written for you. It's just 2. Are those 2 slopes perpendicular? Yes or no?
Yes.
You could check them if you'd like and multiply them together. And what should you get if you multiply them together if they were perpendicular? -1. Or you can just know that they're negative reciprocals. So if ever there was an ask why, there's 2 ways you can state why. You could show that they multiply to -1, or you could write the words, they are negative reciprocals. Depends on how much you want to write. Okay? All right. Yes, it equals -1, so they are perpendicular. Because the 2 slopes multiply to be -1. All right. Questions so far?
Wait, are we supposed to put the question mark there, or are we supposed to put the -1 on the check?
I would put right here the negative. You don't. You're not going to put the question mark. You're going to put the -1.
Your computer got bumped unplugged. It just said it had low battery. I just bumped it.
Thank you very much. I didn't see that. Thank you. Other questions? Fantastic. All right. All right. Are these 2 lines perpendicular? How would we know? We'd know if we knew their slopes. So what's the slope of the first one?
2. No, I'm sorry, 3/4.
Which is it, 2 or 3/4?
3/4.
Yes. And we know that because it's the y equals mx plus b, and the m part is the 3/4. All right. So the first one, m1, is 3/4, right? If I call this m2, what's its slope? -4 over 3. All right. Without multiplying them together, can you see if they're perpendicular or not?
They are.
Are they negative reciprocals of each other?
Yes.
Yes, they are. You could show that you could multiply them together and get a -1 if you desire, noticing that the 3's in the numerator and denominator cancel, and the 4's in the numerator and denominator cancel, leaving you with just a -1 left. Yes, they're perpendicular because they multiply to be -1. If you didn't want to go through all that, you could just know that they're perpendicular because they're negative reciprocals. I personally prefer the negative reciprocal thing than the negative multiplying them together. All right. Let's do some homework problems. Number 1 and number 5 on 3.7. All right, so number 1, they want, I didn't put the instructions on my PowerPoint up here, but we can read them. The instructions say,
Write the slope intersect form of the equation of the line described.
very good, write the slope-intercept form of the equation with this information. First, it's going to, the line that we have, the line we have is going to go through this point and be parallel to that line. So what slope will it have if it's parallel to this line? Will it have the same slope or the negative reciprocal slope?
Negative reciprocal, right? Wait, parallel?
Yes, parallel.
Oh.
Same slope or
Same,
negative?
same.
Same. Okay. So what is the slope of this line here? 3 over 5. Do we agree with that?
Wait, which one? Yes.
Yes, 3 over 5. Amy, you got that? You understand what's 3 over 5? Josie, how about you? You got that? You finding it? Very good. You got it. Okay. All right, let's 3 over 5. You have done these problems many times now. You have a slope. You have a point. What equation do we plug all this into?
Y equals mx plus b.
Wait, I thought it was... Oh, yeah.
Yeah? I want you to do this. I'm going to sit right here and do it too. And then you will compare at the end. This is the B I got. Want to compare?
Yeah, I got the same.
Okay, so everything's good. Am I finished when I found B?
I'm not done.
No.
Okay.
Okay. Wait.
I feel like this is wrong. That's what I got too, but I feel like we did something wrong. Because of course they're going to have the same slope because we used the same slope for both of them.
Okay, so are these two lines parallel? Is this line and this line parallel to each other?
Yes.
Why?
We used 3/5, 6.
Because they have the same slope, right? And so the question now is this 5 over 2? Does it go in, does that line cross 5 over 2? 5 comma negative 2? We could check it if you really want to by plugging in a 5 right there and a negative 2 right there and see if when we do that, see if it equals out. So what, is it going to work?
Huh? I'm lost.
Oh, my bad. Back up. No, other way around. If we plugged in the y of negative 2 and then 5 there we go, my bad. Then, will it turn out? If I plug the 5 in there, will I get a negative 2 on the other side?
Yes.
Okay, so if I take, yes, because...
The 5s will cancel and then you'll be left with 3 minus 5.
Which is negative 2. Okay, so did I answer your question right?
Yeah.
Do you have more confidence in yourself?
Yeah, it felt like we were doing something wrong because of course they're going to have the same slope because we used the same slope to prove it.
In this case, we're not proving anything, we're finding something.
Yeah, but it's always going to be parallel because we used the slope.
And we want it to be parallel, so we have to use that slope. It's the only way we could have it be parallel. So we're not proving that it's parallel. We're using the fact that it is parallel, and we're finding the line that goes through that point and is parallel. Okay?
Yeah, we're not proving that it's parallel. We're just drawing a line that is parallel.
Yes. So this is, so if it's like this. I have an x on my axis. I have the point 1, 2, 3, 4, 5, and negative 2. And there's my point right. This is very crude. Right there, right? And I need it to have a 3 over 5 slope. So up 1, 2, 3, and over 5. 1, 2, 3, 4, 5. Very crude, very crude. Okay? We want to know what the equation of that line is. Because it's parallel to this one. Okay? Did that help you? Okay. Let's now do this one. Number 5. This time, we want the equation that goes through this point, but not parallel, but perpendicular. So, what will my slope be so that it's the perpendicular slope? I'm going to put the little perpendicular sign in front.
Negative reciprocal.
The negative reciprocal. What is the reciprocal of 5 over 6?
6
6/5.
Okay,
Except
very good.
it's not
And then
gonna
how
be-
do I make it the negative reciprocal?
Well, it's already negative on mine.
Right,
Uh-huh.
so we leave it positive. Okay, so
I'm looking at the, okay.
okay, all's good. So we leave it positive. So we have a point, negative 1 comma 3, negative 3, and we have a slope. We just do the stuff you've been doing in homework for about 2 weeks now, for every day for 2 weeks almost. So I'll let you work on that and check up here every so often if you'd like.
Oh, okay.
Okay?
Which is,
What in the world? They kept a fraction for us. It didn't cancel this time. So now what do we do? I'll wait for you to catch up, because what in the world? We have to do fractions?
What? I can keep it.
Did I do something wrong? Is this what you guys got?
No, this is what I have.
What?
Is that what you have, Heidi?
I'm not sure. Oh, I think I know what I did.
What I have.
Do you know you have a fraction button, Amy, that adds and subtracts fractions on your calculator?
I don't know, but I wrote the wrong thing down when
Hi, did you have a fraction button on your calculator?
Yeah.
Okay, good. You know where it is. Josie, do you have a calculator? Do you know that it has a fraction? Your phone doesn't, but your calculators do, and I'll show you on some of the calculators so you can see. All right, so I need to move this 6/5 over to the other side. How do I do that?
I gotta redo this on this stuff.
Add, subtract, multiply, divide to move it over.
Add.
Add. I'm going to let Amy catch up. I'm going to add 6/5
So that would be 21/5.
and add 6/5. Okay. This 3 is 3 over 1. I need it to be fifths. If you don't have a fraction button, it's got to be 15/5.
15, yeah, because I didn't.
Negative.
Yeah, negative 15.
Ooh, that's terrible writing. I need to move some things around here. Let's move this underneath this so you can kind of see it a little better. And
So
that just came over here and become 15/5. I have negative 15/5 plus 6/5.
9/5. Negative 9/5.
Negative 9/5 equals B. I'm going to pause this, Amy, and show you where your fraction button is on your calculator. Are we finished?
No.
All right, what do we have to do to get this equation?
Y equals 6 over 5x, and
Yes.
then plus negative 9/5.
I'm going to do just, instead of plus and minus, I'm going to just do
Yeah.
minus 9 over 5. All right. This line goes through, if we did everything right, it should go through the negative 1, and it will be perpendicular to that line.
Okay.
All right? This is the algebra that you will be doing for this lesson.
So even
Question?
though this has different wording to it, it's still the same process?
The only difference between these two problems
This one's...
is one's parallel and one's perpendicular.
Yeah,
So the
I see.
parallel ones will have the same slopes. So when you see the slope for the parallel ones, you will just use that exact number. But when you're doing the perpendicular ones, you will do the negative
Flip it.
reciprocals.
Okay.
Yes. Okay? All right. So it's the same process as before. So by me having you, we did that stuff at the very beginning, and all that work that you've been doing for 2 weeks made this lesson easier because you didn't have to learn all the algebra part. You only have to learn one little piece about what the slopes are. Does that make sense? Okay. Questions? All right. All right, you learned that parallel lines have the same slopes. You learned that perpendicular lines, you can multiply them together to get negative 1. We preferred a different, at least a couple of us preferred it, I don't know, but everybody in the room, what's another way of seeing, instead of them multiplying to negative 1, they're what? Negative reciprocals. All right.
Wait, so is that all we're learning for today? Is the rest of it just review?
Yes.
Yes.